MQTT IoT stands for Message Queuing Telemetry Transport and is a protocol in the popularly growing system of IoT, or the Internet of Things. This system consists of interrelated devices automatically exchanging data with one another. However, devices that use MQTT do not directly exchange data with one another. Instead, they utilize an MQTT broker. All kinds of devices utilize MQTT, like coffee makers, thermostats, temperature sensors, cell phones, and, yes, BRX PLCs. Some, or all of these devices, might make some of their data available to other devices by publishing that data to the broker. Other devices might need that data, and so these devices will subscribe to those data via the broker. Usually devices do one or the other. The BRX PLC can do both. What does the broker do? It receives published topics. It distributes topics to subscribers. And it sends the last will and testament, or the LWT, to subscribers if a client ungracefully disconnects. That is, dies, so to speak. What does the client do? A client provides the broker with his own keep alive time and QoS, or quality of service. Optionally, he can publish his own topics, their associated retain bit, and his own last will and testament. Optionally, he can also subscribe to topics. So, what is a topic? Very simply, a topic is the name you give to the data, like temperature or PSI or whatever. How about payload? Payload is the value the topic has. In other words, if the topic is temperature, then the payload would be, say, 79 degrees F. Message. This is the topic plus the payload. This is actually what's exchanged between broker and client. What is the QoS, or quality of service? There are three values for the quality of service: 0, 1, and 2. 0 is at most once, and it means that a message is sent once. It relies on TCP/IP to get the message to the interested device. 1 is at least once, and this means that a message will be transmitted until an acknowledgement is received from the receiver. So it could be transmitted multiple times, but guarantees the receiver gets it at least once. 2 is exactly once, and this means that the message needs not only an acknowledgement from the receiver, but other qualifying exchanges as well. The BRX PLC does not use a QoS of 2. Retain. This bit is associated with a published topic, and it tells the broker whether or not to retain this topic even after sending it to the subscribers. If it is set to not retain, then the broker will delete the topic after it has sent it to the subscribers. Keep alive time. This time value tells the broker how often he should hear from the client before considering him to be dead. If publishing, subscribing, and updating is happening between broker and client faster than the keep alive time, then all is well. If, however, for some reason, there is no activity between them, then the BRX PLC will purposefully ping the broker at about 75% of this value to let him know that he is not dead. If he does not do this and the keep alive time expires, the broker, knowing this value, will consider the client to have died. Last will and testament. Now this is a funny term, but it's appropriate for this use. This is a topic published to the broker to tell him essentially this: if you haven't heard from me within the keep alive time, then consider me dead and send this particular topic to all those other clients who are interested in my well-being. If the client therefore dies, subscribers will get his last will and testament. If the client disconnects gracefully, that is, he sends an MQTT disconnect, then the broker will delete his last will and testament without sending it to anyone. Session type. There are two kinds, clean and persistent. Clean. First, let's say the connection is disrupted and the client disappears. The broker then deletes or cleans this client's subscriptions. When the connection is restored, the client must resubscribe to the topics that he's interested in. Persistent means that he will not clean up after the client disappears. So, once again, let's say the connection is disrupted, but this time the broker keeps the client's subscriptions. In other words, the subscriptions persist, and even queues up messages for the missing client. Thus, when the connection is restored, the client does not have to resubscribe and even receives any queued up messages. MQTT was introduced in Do More Technology version 2.3 in June of 2018. It had no TLS or SSL encryption support, only supported a QoS of 0, only a clean session type was allowed, and there was no user-specified client ID allowed, and the only data that you could publish was text. Also, whatever was subscribed to was stored in text in the bricks. This means if the data you needed was a numeric, you had to use other Do More instructions to convert it from a string to a numeric. Also, of course, the MQTT pub and MQTT sub instructions were added to facilitate using MQTT in a BRX PLC. Version 2.52 came out in April of 2019. In this version, TLS and SSL encryption was added, also a QoS of 1 was supported, and also a persistent session type was added. Also, 2 new instructions were added that can be useful when using MQTT. The reason being, many times data you get from a topic comes back in the popular JSON data format. So to aid you in this data format, both sending and receiving, instructions JSON build for building your own data in JSON format, and JSON parse for interpreting data that you receive in this format were added. Version 2.62 came out in August of 2019. This version changed the MQTT pub and MQTT sub instructions so that they can send and receive numeric data instead of text only. Version 2.74 came out in April of 2020. This added a tool for viewing JSON data in a pretty format. JSON data comes back in a single string, yet it can have many nested topics or objects. Viewing it as a single string is very difficult. The new tool allows you to view the JSON data string in such a way that it's easy to view and to pick out what you're interested in. Also, the client ID that in previous versions was generated automatically by Do More was now allowed to be user specified in a 64-byte string. This concludes the overview of MQTT for BRX. To see how to avail its use in the BRX PLC, check out our simple MQTT example video.